Assalamualaikum warahmatullahi wabarakatuh. So this is subject SFB 36102 automotive safety. So we are currently in chapter 4. So chapter 4 is biomechanic and occupant simulation. So this is just a short video for to explain to you the the, the calculation part of the some area, for example head protection and chest protection. Alright, so biomechanic and occupant simulation. So biomechanic is a study the structure, the function of the biological system such as human, animal, plant, organ, and cell by the method of the mechanic. Alright. So biomechanic means the biological plus mechanical. Okay. So when we apply the application of the application of biomechanic is the mechanical principle using a mechanical principle in the living organism. Okay, especially during the especially injury during the due to the accident. So this is include the bioengineering research apply of the mechanic and living organism, the application of the engineering principle to and from the biological system. Alright, so this is involving the engineering, epidemiology, traumatology, anatomy, biology, and psychology, physiology. Alright. So in term of injury, we have we have a classification of the injury. So known as abbreviated injury scale (AIS) and overall abbreviated injury scale. So AIS refer into the individual injuries such as hand, leg. So this is considered as a AIS. But for the OAIS is overall abbreviated injury scale refer into the overall human body after the collision, after the accident. Alright, so the purpose of the AIS and OAIS is to describe the injury anatomically, to standardize the injury terminology, to rank the injury by severity, and to facilitate the comparison of the injury's body. Okay, so in terms of classification, we have eight classification of the AIS known as AIS 0, AIS 1, AIS 2, 3, 4, 5, 6, and 9. So AIS 0, the code for the AIS 0 is a no injury. So after the collision, sometimes there are no injury. So this is under the classification of the AIS 0. So AIS 1 is a minor. Minor refer to the example is an outpatient. So outpatient, we visit the clinic to for the medical treatment, but we consider as an outpatient. Okay, and moderate is a still outpatient, but we need to follow up. Which follow up? Okay, serious injury refer to the warded. If any injury but warded in hospital, consider as consider as a serious injury. Severity consider as a what is different between severity and critical. Normally, severe refer to the CC ward, and critical refer to the IC ward. Alright, and maximum injury. Some of people say this is virtually unsurvivable. This is refer to some situation of a coma. Okay, but some of the injury is unknown. Unknown means cannot detect by the doctor. Alright, but maybe coma, we don't know. Alright, so that's why AIS 9 is under category of unknown. Okay, so in terms of injury, we have two type of injury: external injury and internal injury. The injury mechanism external for the human part, broken considered as external injury. Internal injury, we have a three type of the internal injury: concussion, spinal injury, chest injury. So this is the example of the concussion, spinal injury, and we have a chest injury. Okay, alright, so why I show this one to you. So what during if you are working with the automobile company, so what they need to do is to design the part, to design the vehicle, to make sure the occupant is safe inside the vehicle. Okay, all right. So we see first how to protect the head of the occupant. So this is because of the confusion. All right. So the philosophy of the head protection is for the criteria is we have two criteria. Number one is head protection criteria HPC. So the value of the HPC must be below than 700. If below than 700, consider safe. This is targeted by the automotive manufacturer. Okay, and in terms of head injury criteria, actually based on the study, this must be below than 1000. So we have different 300 here. 300 considered as a buffer, safety buffer. Okay, actually target by automobile company is below than 700. All right, so how to get below the 700 HPC and HIC by using this formula. Okay, so HIC consider to calculate the number of the value of HIC must be using this formula. So this is T1 and T2. So T1 refer due started of the accident. T2 is the end of the accident. That means the duration of the accident. All right. So A is acceleration. Okay, so this formula, when we simplify this formula, actually HIC equal to A power of 2.5 time the difference of the time. So that's mean T2 minus T1. Alright, let's see one example. If let's say T1 is a 0 millisecond, ms stand for the millisecond. Alright, so T2 is a 10 millisecond. That means here is a 0 times 10 negative 3. So here is a 10 times 10 negative 3. Okay. Alright, so how to calculate the HIC? So by using this formula, HIC equal to A 100 power of 2.5 time the what is the different time? Different time is a 10 minus 0. So that means time 10 for the millisecond is a negative power of negative 3. Okay, so the result is a 1000. So what is your conclusion? So that means if let's say this condition considered not safe because the target of the HIC is must be below than 1000. So now with this situation resulted one HIC is 1000. So that means this is unsafe condition. Alright, let's see one exercise. Alright, simulation results show the changing of the acceleration started from 70, 80, 90, 100, 110, and 120. If a T2 and T1 is constant, that means T1 is 0, T2 is a 10 millisecond. So analyze the result of the HIC. Alright, so for example, this is for the 7G, 7 the power of 2.5 times 10 power of 10 power of negative 3. Actually, this is negative 3 power of negative 3. So the result is a 410. Then 80 power of 2.5 times different time, the result is a 572. 90 power of negative 2.5 times 10 times negative 10 negative 3, 768. So for the 100 power of 2.5 times 10 negative 3, the result is a 1000. Okay, for the 110 power of 2.5 times 10 negative 3, the result is a 9. And for the 120, sorry, here is 110. 120 power of 2.5 times 10 times negative 10 power of negative 3, the result is 1577. So what you can conclude from this situation? So that means if we plot the graph of the x and y, okay, the graph of the, for example, we start with 70, 80, 90, 100, 110, and 120. So what we can, how the graph look like? For example, here is for 10, this is 572, here is 768, 1000, 12, 1269, and 1577. Alright, so this is the our graph of the x and y between a and between acceleration and HIC for the different time of the 10 millisecond. So what we can conclude here for the first one, here is about 700, here is about 1000. Okay, here is a 1000, here is a 700. So for the head protection, actually must be below than 700. Okay, for the HIC below than 1000, but the target from the automobile company is below than 700. That's mean only these two situations consider safe situation. This is considered safe, and this is considered unsafe condition. For the 100G, 110, and 130, this is unsafe. Okay, and this is marginal asset. We can improve the situation. How to improve? We need to improve the airbag, we need to improve the seat belt. Okay, so this is about the HIC. So the second one is the chest protection. Chest protection just target the movement of the viscous criteria must be below than 1 meter per second. Okay, but another one, the important thing is that the neck protection, how to avoid from the spinal injury. So how to calculate the spinal injury? We are using the NIJ. This is the NIJ FZ over FZC plus MOYC over MYC. So the target of NIJ must be below than 1. Okay, for example, this is how to calculate the NIJ. Here is a FZ 460, FZC 480C divided by 480C plus 135 MOYC 135 plus divided by MYC is 210. Okay, so the result is a 0.96 plus 0.64. So the NIJ result is a 1.6. Okay, so what we can conclude here? So that means for this situation, consider unsafe. Why? Because of the NIC value is more than 1. Okay, NIC value is more than 1. The target for the neck protection, for the chest for the spinal injury, the NIC level, NIC must be below than 1. Okay, so understand? Alright, so for the rest is about the theoretical part. So for example, this is some of the study. Where is the safe area during driving? So for driver, most of safe area is for the leg. Oh no, sorry, for the critical area is a leg. Why? Because most of the seat belt cover leg and above. Alright, so that's only for the short video. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.